All right, so good morning, class. I noticed that some of you are struggling or have questions about the homework when it comes to story problems. I understand story problems are not our favorite. It's hard to pick out the pieces of how to create the triangles, so I'm hoping that this video will help you out. Otherwise, just let me know if you want to do a Google Duo chat and we can talk face to face about it. So I'm going to go through all 8 questions. I will have the key up, if not already, when I post this YouTube video. So, first section, angle of elevation. So we already know it's about looking up at something. But I'm going to show you in the story what tells me that I'm looking up. Because let me rephrase. So you know how when we have a test, it may be jumbled. You have to decide if it's elevation or depression. So here, I see Jack is at the zoo looking up at a monkey sitting on top of a pole. If Jack is standing 24 feet from the foot of the pole and the angle of elevation, so I see here that we're talking about angle of elevation. So we have Jack, and he is at the zoo looking up at a monkey who is on a pole. So here's Jack, there's a monkey on a pole. And I'm just going to say monkey. It's hard to read with this marker, I know, but it says monkey. So if Jack's line of sight is straight ahead, but now he is looking up at a monkey on the top of a pole. Okay, so I have the idea of what my triangle is going to look like. If he's looking up at a monkey, here's my triangle. Now I've just got to fill in things that they tell us. So it says if Jack is standing 24 feet from the foot of the pole, foot is just another word for base. Base means bottom. Jack is 24 feet to the pole, to the foot of the pole. And the angle of elevation that Jack is to look at the monkey is 23 degrees. So he's looking up 23 degrees. And it says find the height of the pole. Well, the height is going to be the leg that is from the base, the bottom, and straight up. In this case, it's the opposite side. So this is what we need to find. So height of something means it's going to be the vertical leg. If it talks about the foot of a pole or saying how far a person is from the base or the bottom, then I'd put the number on the bottom leg. If it talks anything about a ramp, an incline, a slide, a pool, that's like sliding down at an amusement park, like a roller coaster, it's going to be the hypotenuse. So once we have this drawn, now it goes back to what we've been doing over and over, which I hope we're okay on that. If not, let me know and we can talk on Google Duo or Remind, just let me know. So here I see I have opposite and adjacent. I have nothing for hypotenuse. Hypotenuse is sine or cosine, so if there's no hypotenuse, all that's left is tan. So we have tan, and it's always over angle, so in this case they gave us the angle, and it's opposite over adjacent, so x over 24. When we find a missing side, we put our function over 1 and we cross multiply. When x is on top, it's very nice because it's 1 times x is x, 24 times the function, tan of 23. And when you put that in your calculator, and make sure your calculator mode is in degrees, you should get about 10.2 or 10.19 feet. That is how high up the monkey is on the pole. Okay? Let's look at another one. So number 28. The angle of elevation. So I already know it's about something about looking up. From Allison to the top of the Statue of Liberty. So here's Allison. I'll just do A for Allison. This is her normal line of sight, but she is looking up at the statue. And it says the top of the Statue of Liberty. I'll just say statue. All right, so I have an idea now of what my triangle looks like. Now I need to fill in any blanks that they give me. It says the angle of elevation from Allison to the top of the pole. So she is looking straight ahead, but then looks up to the top. So she's looking up 70 degrees. If the Statue of Liberty is 305 feet, all right, that doesn't say that's how far from Allison is to the statue. That's telling me how tall the Statue of Liberty is, where she's looking. So I put it for the height, the vertical side, the vertical leg. How far is Allison standing from the base? So Allison is standing from the base or bottom of the statue, so it goes on the bottom. So now we're finding the bottom side, the bottom leg. Again, notice that a lot of times you're going to see it's tan, but sometimes they can get you, so pay attention. But here again, it's tangent. But actually, I'm glad that we're doing this problem, because if we have tangent of 70 degrees equals opposite is 305 over x. Well, now x is on the bottom. I'm going to show it by cross multiplying, but when x is on the bottom, then we divide the constant and you divide it by the function. Now, it's a way to remember it, but if you want to see it mathematically to know why, we have x times tangent of 70 equals 1 times 305 is 305. Well, now x is multiplied by something, so I need to move tangent of 70 over. If it's multiply, I divide. Oh my gosh, we're dividing like I said in the beginning. So tan of 70. So now notice when x is on the bottom, it is the constant divided by the trig function. So when we put that in our calculator, excuse me, we see that Allison is about 111.01 feet away from the Statue of Liberty. All right? Okay, so let's look at number 29. 29, Caitlin's mom is standing at the bottom of a water slide. Well, a water slide goes down, right? You go up the stairs, you get to the top of the water slide, and you're sliding down. So this might be involving hypotenuse. Let's see. So we have the mom. She says that she's standing at the bottom of the water slide, waiting for Caitlin to slide down. All right, so we'll say Caitlin. It does say Caitlin, I swear. So she's looking up at Caitlin, who's at the top of the slide, who's about to go down. So I can see that. Also, notice it says angle of elevation, so I know she's looking up. So whenever it's angle of elevation, notice that the triangle looks the same every time. Every time. If the top of the slide is 40 feet from the ground, so the top of the slide where Caitlin's at is 40 feet from the ground, that's telling me in a different way what the height of the slide is, how far she went up the steps to get to the top of the slide. And the slide, so the slide, a ramp, you're sliding down, the hypotenuse is 48 feet. Excuse me, what is the angle of elevation from Caitlin's mom to Caitlin? Well, the mom is looking up at Caitlin. So now we're finding the angle this time, but we're finding the angle of elevation. Same process. But notice, now we have our opposite side. There's no adjacent, but we have hypotenuse. Well, if you think about SOHCAHTOA, the only one, first the one that has hypotenuse is either sine or cosine. But if we have opposite, the only one with opposite and hypotenuse, OH, is sine. So we're using sine now. Sine of x equals opposite over hypotenuse. And then what we had learned digitally about finding the angle is trapped by sine. So to do the inverse, that way we can free x, get it out of sine, we do the sine inverse. It's the same as opposite of dividing is multiply, adding is subtracting. The opposite of sine is sine inverse to get x by itself. So you would hit second and then the sine button so you have a -1 on your calculator. And then after that you put in your ratio and hit enter. So if we do that, we get about 56.4 degrees. So the mom is looking 56.4 degrees. So from her line of sight, she's looking up 56.4 degrees to see her daughter at the top of the slide. Okay? All right. Next one. Number 30, Jaden. I wonder if they mean Jaden Kelly. I'm just kidding. So Jaden is looking up at the top of a 56-foot rock climbing wall. Looking up, so angle of elevation. And I did mention, I believe it was on Google Classrooms. I'm kind of fast forwarding. It says angle of depression, and I had said make sure that you change that to elevation. Because he's looking up, right? That sounds redundant, doesn't make sense. So that's supposed to be elevation. So Jaden is looking up at the top of a 56-foot rock climbing wall. So here's Jaden. I'll do J for Jaden. And then he's looking up at the top of the rock climbing wall. I'll just write rock wall. Terrible writing, don't judge. So I just drew this. I know he's looking up. So here's my angle of elevation triangle. So if, oh, and I should backtrack. It said at the top of a 56-foot rock climbing wall. They should have said a 56-foot tall rock climbing wall maybe, but that's telling you the height, the vertical height of how tall the climbing wall is. If Jaden is standing 15 feet from the base, which means bottom of the wall, base means bottom, so bottom of the triangle. 15 goes here. What is the angle of elevation from Jaden to the top of the wall? So here's Jaden, he's looking at the top of the wall. So again, we're finding the angle. So let's see, we've got opposite and adjacent, no hypotenuse. So if I look, the only one that has opposite and adjacent, nope, opposite adjacent, we're using tan. All right, so tan of x equals opposite the angle is the rock climbing wall, 56, over the base, the bottom of how far Jaden is to the rock climbing wall. To get the angle by itself, we do tan inverse, and then the ratio, 56 divided by 15. And we see that Jaden is looking up at about 75 degrees. Okay, so this is angle of elevation. Now let's talk about angle of depression. So angle of depression, make sure I have my numbers in order. So number 31. So it says the angle of depression. So I know that if I'm looking straight ahead, I'm looking down at something now. Depression, you feel down, you're looking down. From a helicopter to the top of a launching pad. Now how I draw this triangle, you might do the other way I taught you because there's two triangles you can draw. But to me, it just visually makes more sense that if I have a helicopter that, let's see, helicopter, it's in the air and it's saying the degrees to the landing pad. So if you have a helicopter in the air, it's looking down and seeing where it needs to land. So this is the helicopter's line of sight looking straight ahead. But now the helicopter's looking down, not the helicopter, but the pilot, is looking down to see the landing pad to adjust his speed to get to the landing pad in time and safely. So, angle of depression from the helicopter to the pad is 37 degrees. So he's looking down 37 degrees. If the helicopter is 1,250 feet from the ground, all right, so that's saying from the ground, so the helicopter to the ground. So if I draw it like this, we would see, okay, 1250 we would put here, but based on my triangle, parallelograms, or in this case rectangle property, that means I can put 1250 here because this is still the helicopter moving forward. So from this point to the ground, 1,250 feet. All right, what is the horizontal distance from the helicopter to the launching pad? Well, I understand that we would think it's this one right here, right? Helicopter to launching pad. But again, properties of parallelograms, then I would put it here. Helicopter to the launching pad, that's straight below. So now I see I am finding a side. We have opposite and adjacent, no ramp, no hypotenuse. So what do we use? Tangent. So tan of 37 equals, opposite is 1250 over x. So x is on the bottom, so if I recall, well, if x is on the bottom, I divide. What do I divide? The constant divided by the function. And we had shown that previously when we cross-multiplied on angles of elevation. So the constant divided by the trig function. And then you would get your answer, and that is about 1,658.8. And that makes sense. If it was something really small, we have a problem. Because if he's this far up, this high up above the ground, the altitude, he's going to need a good amount of distance to slow down and properly land. Now, I know some might want to put x here because that's how he's traveling to the landing pad. But it said if the helicopter, where was it? What is the horizontal distance? Well, if I put this here, that's not horizontal. This isn't horizontal. This is horizontal. Okay, and then you would get your answer of 1658.8 feet. All right, number 32. Claire climbed to the top of a 164-foot lighthouse. So here's Claire. And I see that, actually I'm going to draw it a little differently, but I understand if you drew it the other way. Claire climbed to the top of a 164-foot lighthouse. So she climbed to the top of a lighthouse. I'm just going to draw a rectangle, pretend that's a lighthouse. So she went up and she's at the top of a 164-foot lighthouse and spotted a water fountain on the ground below. So this is her line of sight. She looks straight ahead at the top of the lighthouse. And she looks down below and sees a water fountain. Okay. Well, I'm going to backtrack. She climbed 164 feet to the lighthouse, correct? Yes. Well, parallel, I would put 164 here because that's how tall something is. That is your vertical line. If the angle of depression from the lighthouse, where Claire is, to the fountain, so she's looking down to the fountain, is 54 degrees, how far is the fountain from the base of the lighthouse? So here's the water fountain. Here's the base of the lighthouse. We'd want to put X here, but with my triangle that I'm personally drawing, I would go parallel and put X here. So now I see again I have opposite and adjacent, which is tangent of our angle, always the angle in parentheses, and then opposite over adjacent. And when I cross multiply, X is on the bottom, so it's 164 divided by tangent of 84. And you would get that X equals about 119.2 or 15 feet. That is how far away Claire is to the water fountain. So if she climbed down the lighthouse, she would walk 119.2 feet to get to the water fountain. Okay? All right. Last two. So now this says, while on a hot air balloon ride over Washington, D.C. So if you're in a hot air balloon and it's a ride, that means you're in the air at this point because you're riding on the hot air balloon. Xavier spots the White House below. So Xavier is in the hot air balloon. So he's up in the air. And he sees, this is his line of sight if he keeps going straight ahead with the hot air balloon. But then he looks down and spots the White House. So here's my triangle. Now I've got to figure out, where do I put everything? If the horizontal distance from the White House to the hot air balloon is 1,478 feet, well, my horizontal line in this picture is right here. Xavier to the White House, which is parallel. So 1478. And the hot air balloon is 2,109 feet from the ground. So here's Xavier in the hot air balloon. This is how far he is from the ground. With my triangle, I would put it on this leg, the vertical leg, because that is the altitude. 1478, 2,109. What is the angle of depression? So we're finding the angle now. So now it would be, let's see, yet again, tangent, opposite and adjacent, but now we're finding the angle, and it would be 2,109 over 1478 because opposite, and this is your adjacent. We're not given hypotenuse at all. So to get x unleashed from tangent, we have to do tan inverse of our trig ratio. Notice why we spent so much time, well, not so much, but we spent a good amount of time on trig ratios, because notice how it connects with this. So then you hit second tan, put in your ratio, and you would get about, if you said 55 degrees, that's fine, because it's 55.98 degrees, but it didn't tell you how to round. So if you said if you said 55 degrees instead of 54.98, that's good too. Okay? All right, last one. So for this one, Michael is standing on the top of the bleachers. Okay, he's on top of the bleachers watching the football team play. He spots the team mascot on the field. So if he climbed, as you climb up the stand, you are above the ground. So Michael is above the ground. This is his line of sight if he looks straight ahead. But you'd be wanting to look down to see what's going on with the football team. So it says he spots the team mascot. So apparently he wants to look at the mascot, or it just grabbed his attention for a moment. If the bleachers are 40 feet tall, so Michael climbed up 40 foot tall bleachers. Parallel, I would put it on the vertical, the height of my triangle that I created. And the horizontal distance from Michael to the mascot is 68 feet. Well, the only side that's horizontal is right here. So then I put 68 here. What is the angle of depression? Because he's looking down at the mascot. So we're finding the angle. You're finding the angle. I'm going to write down here. So opposite over adjacent is tangent. You're finding the angle. It is opposite is 40, adjacent is 68. To get x by itself, because it is trapped by tan, we've got to do tan inverse of 40 divided by 68. And we get about 30.46 or 30.5 degrees is how much he's looking down from his line of sight. Okay, so just to recap, if it says horizontal, if it says from one person or object to another person or object, that's your horizontal. If it says how tall something is, or how the altitude is, how high up the pole the monkey went up, that is your vertical. If it talks about a slide or a ramp or going down at, how do I say this? Usually it's going to be a slide, water slide, things of that nature, like a ramp. If it was a skateboard going up the ramp before launching off, it'd be hypotenuse. Okay, so keep that in mind. But first decide, is it angle of depression where I'm looking down? Or is it angle of elevation where then I am looking up? See the difference in triangles? Elevation, looking up at something, or depression, looking down at something. So notice these two different ways of drawing the triangles, but it depends on depression or elevation. Once we draw it, it's then going back to what we've been doing to find sides and angles. All right, so hopefully this helps. If not, please contact me. I'll be happy to help. That's what I'm here for. I want you to be successful and do well. So just let me know. All right, everybody. You all have a good one, okay?